Hello everyone and welcome to the second lecture of this seismic inversion and interpretation series which is a part of a PMRF teachings. So here I am Anjali Dikshit and today we'll talk about the basics of seismic. So now the first question come like what type of seismic survey we do. So there are two type of seismic survey. One is onshore seismic survey and second is the offshore seismic survey. And from this picture, I think it's very clear that in onshore seismic survey, we acquire the seismic data on land. However, for the offshore survey, we acquire the data on the oceans. And the another major difference that these two surveys has is that for onshore survey, we use geophones to receive the seismic wave response. So here are the geophones that you can see, and on the other hand for offshore survey we have been using a hydrophone which are light on to the streamer so that the boat can they can move along with the boat or a ship. So moving next, now let's understand that what are these waves exactly. So, for seismic survey, we generally like seismic waves consist of two major categories. First is the body wave, second is the surface wave. But for the seismic data, we generally if we are interested to understand the deeper structures of the Earth's subsurface, then we acquire the body waves, which have the another two categories of waves. First is the P wave and the second wave, sorry, and second is the S wave. So here you can see in this figure that for the P wave the particle motion is in the horizontal direction where it caused the wave caused the compression and the dilation. And for the S wave it's completely different. So here the particle motion is in vertical direction. And apart from this body waves, the another category that I've talked about is the surface wave. So it also has the two subcategories. First is a love wave, second is a railing wave. And these are the surface waves, so generally we don't acquire surface wave for understanding the subsurface features, like deeper features. But however, these waves are very disastrous in the earthquake scenario because this is the most experienced on the surface. So the shaking that you experience during the earthquake, that is majorly caused by these love waves and the railing waves. So moving next, now we acquire the data, but the raw form of data is not very easy for to make the interpretation or to identify the subsurface features that we have. So for that we need to process that raw data into the processed one that could be the pre-stack data and the post-stack data. And don't worry, we'll come to these technical jargons as the progress of this lecture series. So in a very simpler manner, this is the seismic wavelet, and from seismic wavelet I meant that the source waves that you have seen even in earlier, the truck was injecting some sound seismic waves. So this is the source wavelet or the seismic wavelet that we inject into the ground. And when these injected wavelet get convolved with the subsurface reflectivity series, we get the seismic amplitude data. But before getting into this processed section, we need to do the processing. And under that processing part, there are major three steps that we need to perform. First one is the deconvolution, which enhances the temporal resolution by suppressing this seismic wavelet into suppressing the noise into this seismic wavelet, or I would say the reverberation that you can see over here and here, and also make it as a spike. Second is the stacking. So what stacking does, like generally we do the common midpoint stacking to enhances the signal to noise ratio. And third comes the migration step. So with the help of migration, we try to bring the dipping events into their true subsurface location. So after performing all these major steps through the processing, we get processed seismic data. And with that processed seismic data, we get the information about the amplitude variation. But this amplitude variation definitely will give me the idea about, okay, these are the major amplitude response. So definitely there would be a boundary between these two, which is separating these two lithologies. So this is the prominent boundary, or I would say the reflector. But this information is not sufficient if we want to understand the subsurface structure, or we want to do the reservoir characterization for oil and gas industry. So we need an inversion scheme to get these elastic parameters about the surface. And from elastic parameters I mean that impedance, porosity, permeability, lambda, mu, Poisson's ratio. So to get all these elastic attributes of the subsurface, we need to do the inversion. And about this inversion, I'll come with another lecture series where we'll discuss about this inversion uh, in detail. So moving next, now you must be understanding that how seismic data is relating with these elastic attributes. So here is the basic formula. Why I'm saying it is a basic, because it is based on an assumption that the subsurface media is isotropic in nature. So this is how the velocity, like p wave velocity and the s wave velocity, is associated with the elastic parameters. First is the mu, second is the compressibility, and rho is the density of that media. And this table is representing the will give you the general idea that what could be the range of all the lithology, where you can see that for granite, because it's very compressed and compact, so you'll get very high p wave velocity and comparatively less s wave velocity. And similarly for clay, because it's loosely compacted, so the p wave velocity is significantly lower than it was in granite. So thank you all for listening me. I hope that this lecture will be helpful for you to understand the basics of seismic. And in the next lecture series, I would give a lecture about the seismic impedance that we have discussed, like seismic inversion, that how we do the seismic inversion, what is the need of that seismic inversion. So all this will understand in the later lecture. And thank you all for listening. Have a good day.